Okay, here we go with chapter 4.3. No, wait, 1.3, sorry. This is, however, a review for the whole chapter, so let me just fly through this. If you want to write it down, I'd suggest you pause the video and look. I'm just going to run through this, okay? Base exponent. Multiplication law means they have to have the same base. If they're the same base and you're multiplying, all you do is add the exponents. Boom, boom. So x to the power of 5. Okay, x to the power of 5. Now, if we go down here, the division law. Same thing, you must have the same base. And then you subtract the exponents. So you could have it as x to the power of 5 over the x to the power of 3, or you could have a division. It simply means 5x's over 3x's, bang, bang, bang. You cancel. 5 minus 3, it's going to be x squared. Okay? Let's keep going down here. Power to a power. Well, if you have a power on a variable or on a number with another power on top, power to a power, that's x cubed twice. So you multiply them. 3 times 2 is 6. X to the power of 6. Okay? Power of a product. Understand that this 4 on the outside applies to the x and to the y. That means that would be x to the power of 4, y to the power of 4. It also means that if I have something like 2x to the third, that's 2 cubed, which is 8x cubed. Okay? You have to cube both the number and the variable. Okay? And then power of a quotient, same thing. If it's an exponent on the outside, oh, let's do these, sorry, I didn't see these. X squared y cubed, right? Do this one real quick. Power of a product. So x squared to the power of 3 is x to the power of 6. Y cubed to the power of 3, y ninth. Done. Okay? Here, 4 squared is 16. Power to a power, x to the 10. This is grade 10. Radical stuff. If you want more information and more detail, go check out the grade 10 pre-calc 10 chapter 4 playlist. Okay, there's 5 videos in there and it deals with all this stuff. Negative exponents, basic exponent rules, a lot of the stuff that you need to know for this chapter. Okay, so again, that's pre-calc 10 playlist chapter 4 on this YouTube channel. Okay, if you found these, you'll find those. Power of a quotient, here you go. So what this is, simply x to the power of 15 over y to the power of 10. That's it. Nothing new in this stuff, okay? So these, again, if you wanted to write those down and have them in your notes, probably not a bad idea. Now, what we are going to do right now is the simplifying radicals. This is the actual chapter that we're looking at, okay? So pre-calc 11, obviously 1.3, simplifying radicals. We looked at simple ones last year. For example, if I have the square root of 20, you need to know your perfect squares, the square root of 4 times 5, which is the square root of 4 times the square root of 5, which is 2 root 5. We did this already, but we only used numbers. Now we're going to be dealing with radicals as well, okay? But let's just introduce. Radicals can be written as fractional exponents. Please remember, cube root of x is x to the 1/3. And using variables, the m, the exponent on the radicand stays on top and the index goes on the bottom. Okay, so an example for this would be the 4th root of x to the power of 5 is x to the power of 5 over 4. Often good if you just want a decimal answer, you can convert it to an exponent, put it on your calculator, a little bit easier. Now, to simplify radicals, folks, it's helpful to have a list of perfect squares, okay? A list of perfect squares, cubes, and so on. And I have made a list here for you. Pause it and copy it down. I'm going to keep going, okay? So these are my perfect squares. These are my perfect cubes, and these are my perfect powers of 4. If you want a few perfect powers of 5, 1 is 1. The next one is 32. And then the next one times another 3, I believe it's 243. And that's really all we need to go. This one's going to be like 1028 or something. But you really only need the first few as we get higher. Okay? So let's jump down here. Square root of 50. Well, we already did that. See if you can beat me. Done. Right? So now, cube root of 80. Cube root. We're doing exactly the same thing, but we're looking for perfect cubes now, not perfect squares. Look along here. Right? So that means that this can be written as a cube root of 8 times 10. So that's the cube root of 8 times the cube root of 10. Cube root of 8 is just 2 times the cube root of 10. Okay, be very careful how you write this, because if I wrote this, maybe bigger, it's kind of hard to see. Is it 2 cubed or is it the cube root, right? So just be aware of that. Let's have a look at these other ones here. 180. Okay, so let's break this down into all its perfect squares, right? What's going to go into 180? 64, no. 27, 5, 6, 7, 8, no. 8 goes in there. 8 times 80, 160. No, that doesn't go in there either. What the hell am I looking at here? What's going to go in there? 27, 5, 10, 64, 5. No, I don't think anything goes in there. So I think it's going to stay as... Oh, I'm looking at square roots. Sorry, not cube. No, square roots. My apologies. Square roots. So 25, 36 I think goes in there, right? 36 times 5. So it's 36 times 5, right? And then I got x squared, y squared, y. So perfect square, perfect square, perfect square, perfect square, perfect square. Square root of 36, 6. X squared, x, y. What's left on the inside? 5y. Obviously we can simplify this and call it x cubed y. All right? So index is very important, what you're going to be looking at. Let's look at this last one here. The cube root of x to the 12 over the cube root of 64. Well, one of the first things we should do is split it up. Deal with them one at a time. Well, this is going to be 12 over 3, so that's going to be x to the power of 4 there. Right, if you wanted to break it down into x cubed, x cubed, x cubed, x cubed, 4 perfect cubes, they all come out, become x to the power of 4. And if you look up here, cube root of 64 is 4. So it's x to the power of 4 over 4. All right? And now let's look at making entire radicals. Okay, putting them together. So we can take them apart, but let's put them in. If I want this 3 here to go back inside the square root, I need to square it. So it becomes 3 squared, which is 9 times 5, so root 45. This is a little tricky because of the negative, but you can see that this whole thing's negative if that's a negative. What happens when you square a negative? It becomes a positive. So do I get rid of the negative or do I not? Well, it should be apparent that you want the answer to be negative if it's negative. They're supposed to be the same after all. So let's leave a negative on the outside. If I want to put the 4 back in, it becomes 16. Let's multiply it by the 5. If I want to put the x squared in, I got to square it, so it's x to the power of 4, and I got an x cubed in there. Now let's combine it. Negative 16 times 5 is 80. That becomes x to the 7th. You've brought everything in by doing the opposite, right? If you want to put it in a square root, you square it. You want to put it in a cube root, you cube it. You want to put it in a fourth root, you fourth it, right? Well, let's check this one out then. So everything's going inside, and it's cube root. 2 cubed is 8. Let's multiply it by the 4. Keep everything together. To put the x in, you have to cube it. Well, there's already an x squared there. If I put a y in, I got to cube it, and there's already a y cubed in there. Now let's just simplify. 8 times 4, 32. X cubed, x squared, x to the power of 5, y cubed, y to the power of 6. Okay? These are the essential bits of simplifying radicals. I do have something else I'm just going to remind you of again. Okay, I think I got a bit of time here. Look at this. If I have the square root of 2 over 7, now sure, that's pretty simple. You can't really take anything out, but we can do this. Split it up like that. And then hopefully you remember that we don't like having funky things in the denominator. Don't like having negatives in the denominator. Don't like having decimals in the denominator. Don't like having radicals in the denominator. So how do we get rid of the root 7 in the bottom? Well, you just multiply it by itself. And then remembering through algebra, whatever you do to the bottom, you have to do to the top if you want it to remain equal. So root 7 times 7 is simply 7. And now you have on the top, root 2 times root 7, root 14. Okay? these are the basic ideas behind simplifying radicals. Okay.